Good morning, N.A.S students. How are you guys today? We will be discussing the acids and bases part 3. Let's start with the equivalence point. The equivalence point is the point at which the number of moles of OH minus ions, which represent the strong base, equals to the number of moles of the H2O plus ions, which represent the strong acid. At the equivalence point, both the H3O plus and the OH minus ions are limiting reactants. Using the pH meter, the equivalence point is reached when the meter reads 7. The pH at equivalence of the titration between a strong acid and a strong base is always equals to 7. The chemical species found at equivalence are H2O, which is neutral, the spectator ions. Remember, the spectator ions are the Cl minus, Br minus, Na plus, K plus, NO3 minus. All of those are spectator ions which are also neutral. And given these facts, the pH equals to 7 is justified. Distilled water and the titration reactions. Distilled water is often added into the beaker or the flask before carrying out the titration process. The addition of distilled water only affects the molar concentration of the solution in the beaker or the flask, simply because when you add distilled water, the volume increases, and when the volume increases, the molar concentration of the solution in the beaker or the flask will definitely decrease. The addition of distilled water has no effect on the value of the pH, which is 7. So adding distilled water prior to titration will not change the value of the pH recorded at equivalence, which is 7. Some of the purposes of the addition of distilled water are listed below and in 3 points. Point number 1. When you add distilled water, you are assuring that the combined electrode of the pH meter is well immersed. Because if it weren't, then it will not give accurate measurements. Point number 2. The pH meter does not give accurate measurements in the concentrated solutions. It gives accurate measurements in diluted solutions, which is accomplished by the addition of distilled water. This is a very clear point. The addition of distilled water, ladies and gentlemen, will certainly decrease the concentration of the solution in the beaker. Now, like mentioned in this point, the pH meter does not give accurate measurements in concentrated solutions. It only gives accurate measurements when the solutions in the beaker are simply diluted. The distilled water will simply fulfill the purpose of the dilution process, because when you add distilled water, like I mentioned before, you increase the volume. By increasing the volume, the molar concentration decreases. Therefore, the pH meter will give me accurate measurements when the solution in the beaker is diluted. Point number 3. During the titration process, we're not allowed to use the burette more than once. If you use the burette twice or 3 times or 4 times, this will increase the margin of error, which simply leads to bad results of the titration reaction. Distilled water will simply help us avoid using the burette several times. So with the use of distilled water prior to titration, we will be just absolutely making sure that the burette will be used only once to avoid having bad results in the titration process. Some major points to pass along to you guys here on the slide. During the process of titration, remember that in the titration process we have a solution which is simply placed in the burette, and the solution could be the acid or the base. And in the beaker or the flask down below, we have another solution which could be the acid or the base. Remember, if the acid is placed in the burette, then in the beaker or the flask we need to place the base, and vice versa is absolutely true. During the process of titration, guys, if the volume of the added solution from the burette is less than the volume needed to reach equivalence, so when V is less than VE, let us just consider that the volume needed to reach equivalence is 12 milliliters. If the volume of the solution is less than 12, the solution in the burette is always the limiting reactant. Now let's look at point number 2. If the volume of the added solution from the burette is greater than that needed to reach equivalence, so when V is greater than VE, then the solution in the beaker or the flask is the limiting. Last point here. The appropriate indicator to be used is the one that has the value of the pHe, which is 7, included within its pH range. Guys, if we were to use the indicator instead of the pH meter, we need to choose one that has a pH range which includes the value of the pHe, which is equal to 7. Let's just give a small example here. If we're using an indicator that has a pH range from 6.2 to 7.4, this indicator is appropriate to be used in the titration process between a strong acid and a strong base, simply because the value of the pHe, which is 7, is included within its pH range. Thank you guys so much for hearing me out. This concludes part 3 of acids and bases. Until you hear from me again, God bless and love you all.